So here we are on to question 9. It is a periodic functions question based on our Ferris wheel here. You can see it rotating around there. Saoirse enters a giant Ferris wheel. She enters a capsule on the Ferris wheel from a platform above the ground. So it's above the ground, so that part will be important. The Ferris wheel is rotating anti-clockwise. Anti-clockwise. Let's see, is our rotation right? It is. And the capsule is attached to the Ferris wheel at a point P. Okay, so the capsule is attached to the Ferris wheel at the point P. The height of P above the ground is modeled by this function here. H of T is equal to 65 minus 55 times the cosine of pi over 15T, where T is the time in minutes after Saoirse enters the capsule H. Enters the capsule H is measured in meters, so H is in meters, and pi over 15 is measured and expressed in radians, as they always are. These periodic trigonometric functions are always in radians. Saoirse exits the capsule after one complete rotation. So after one complete rotation. Okay, state the minimum and the maximum heights. Now, those of you who are with me every week know that I'm always saying about these type of ones, the periodic functions, the trigonometric ones, if you can draw the graph first, it's always the best way to do it because it just makes it so much more obvious what the answers are. However, because I'm making the video here, I'll do it in the order that they're written. So if I had a function f of x equals a plus b, and I'll just use sine here, sine of cx, it'll have to be x because x is my my variable in question. I'm using sine because this one is cos, so it works for either. But I can say my range is a minus b. There, no, I didn't write that right. A minus b, comma a plus b. So a minus b, comma a plus b. So it is like in the context here, it is the constant minus the coefficient of the trigonometric part, and the comma the constant plus that coefficient on the trigonometric part. So in our case, it'll be 65 minus 55 will give you your minimum. That'll be 10, meaning so that like we're 10 meters above the ground here. So that part there is 10. And then the maximum is 65 plus 55, meaning it's 120 meters all the way to the top. Okay, so the height at the top would be 120. So we'll see that again in a moment when we plot it. How long is she in the capsule? So it's important that you understand that that means the period. Like how long is the period? So again, back to f of x equals a plus b times the sine of cx. So the period in that case is equal to 2 pi divided by c. So that's just how it's defined. In our case, so c is the pi over 15. So the period is going to be 2 pi divided by c, 2 pi divided by pi over 15. So that will turn out to be 30. And in this case, the time is measured in minutes. So it's 30 minutes. So the full rotation is 30 minutes. She stays in there for one rotation. So she stays in there for 30 minutes. So that's another 5 marks. Part C1, complete the table below to show the height of the capsule above the ground for any period of time. So here is our function. You can just put in the different values, 0, 7.5, 15, or you could do it on the calculator where you start, you input the function, you say start 0, steps 7.5, end 30, and you're going to get your different outputs. You're going to then plot it, okay, using those points. So you're going to plot this function. It's going to look like this. It's obviously just one rotation, from your lowest point back to your lowest point. So you can see that the period is 30 minutes, okay? So because the time is in minutes and our height in meters, we can see we're going up there to the highest point of 120. So just as a reminder, what I said at the start, like you could have done this part. You could have got yourself those lovely 15 marks, which are pretty easy. And using the graph then, figure out what is the lowest and the highest, 10 and 120. What's the period? 30 minutes. And now we'll be up to 25. So that'd be half marks. Find the rate of change of H with respect to T. So we know that's going to be differentiation. So here's our function. H of T equals 65 minus 55 cos pi over 15T. We know that cos differentiates to be sine. So let me just explain each part here again. So I know some people find this a bit tricky. So if I had y equals sine, or I'm dealing with cos here, y is equal to the cos of x, well then dy dx would be equal to the sine of x. If y was equal to the cos of 2x, dy dx would be equal to cos 2x sine 2x, but I'd have to multiply it by the derivative of the angle. And the derivative of the angle, well, 2x will differentiate to be 2. So you'd have 2 times the sine of 2x. So in our case, what's happening here is this. The constant here will disappear. The minus 55, well, that's just a coefficient. So that's just going to stay there. Nothing's happening with that. Cos of pi over 15t differentiates to be sine of pi over 15t. But I must multiply by the derivative of pi over 15t, which is just pi over 15. And I must do that because it's chain rule, because it's not just cos differentiating to be sine. So I tidy that up. I got to be careful just to make sure that, I know that the pi over 15 here, like sometimes people will make a mistake with this part. They will think that's part of the angle, especially if they leave it there for a while. But of course, it's not. It's not. So instead, what I'm going to do is I'm going to multiply the pi over 15 by the 55. So I get minus 11 pi over 3. The 55 will be gone. Minus 11 pi over 3 times the sine of pi over 15t. And that is the answer to that question. So that's going to be that's going to be 10 marks, right? So we're not far away now. But we can see the next part here, part E and part F, are going to be a different kind of context of the question, different part of the question. It says, as the Ferris wheel rotates, a stationary boat at B on a nearby river becomes visible at point P1. B is 500 meters horizontally from the vertical axis through C of the Ferris wheel at an angle CBO is equal to theta. So here's theta as shown. Find theta in degrees correct to 2 decimal places. Okay, let's have a look. With the kind of question as it's gone so far, you might think this is going to be a tough question to find theta. However, we actually have the information we need to do it relatively easily. We know, okay, it's to do with a Ferris wheel question, right? We know that, but after, once we kind of strip that away, we remember, okay, we can use that to help us figure out how high C is above the ground. Okay, so it's 65. If you remember, it was the 10 meters up to the platform, and then the 50, and then you're going another 55 meters up to the center point. And if you remember, then there was another 55 left up here to bring it up to 120. So it was, those were your kind of key figures, right? So 65 is going to be your opposite. 500 is going to be your adjacent. Well, which ratio uses opposite and adjacent? Of course, it's tan. So the tan of theta is 65 over 500. Theta is going to be the inverse of that, and it's 7.406, which would be 7.41 degrees. Now, how many of you forgot to change it back to decimal places? I bet you there was a few, or to decimals, I should say, and away from radians. I guarantee you there was some people who will not get the full 5 marks because you left it in radians. Okay, we're on now to our final part here. So let's read through this part. So as the Ferris wheel continues to rotate, the boat at B is no longer visible from the point P2 onwards. So from here on, as we rotate further, it's kind of like the horizon. You know, once you go over here, you're not going to be able to see point B anymore. The line through B and P2 is a tangent to the path of P, where the angle OBP2 is 13.7 degrees. So 13.7 degrees. So if I had that triangle there, this angle is 13.7 degrees. So find the length of time to the nearest minute during which the boat at B is visible. Okay, well, this is certainly a question even for myself where, I wouldn't be able to just see what the answer was straight away. I'd have to kind of start and kind of work away at it. So that triangle in yellow is going to be the key one. Okay, that's good. That's going to be the important bit in a while because, when the angle theta was 7.41, well, we could see point P1, we could see point B from P1. Okay. So it's asking us to find the length and time to the nearest minute during which boat B is visible. So let's have a look. We can work out the angle here at angle P1, B, P2. Well, we can work that out to be 6.26. So that's that angle inside there. Now, we can tell, and we know, of course, that the tangent to the circle is going to be perpendicular to the radius of that circle hitting at the point of tangency. So we know that, and we came across that in one of the other earlier questions in this year's paper as well. So we're looking at this. If we look here, so we can work out this angle now that's in green, the angle P2C P1, right? Because we know that there's a 90-degree angle up here. Well, actually, I suppose this angle up here is 90, right? Okay. The angle down here at B is 6.26. And if I take that away, I get 83.74. And that's going to be my angle here at C. So I'm going to use that information now to help me figure out how long the boat is visible for. So just in case anyone was unsure there on it, what we'd be saying is like, we know there's 180 degrees in any triangle. So if we can use this triangle here, let me just go like this to find that angle at C. So we'd be saying 180, but we'd be taking away the right angle 90. And we'd be also taking away our 6.26. But of course, when we take the 90 from the 180, we're down to 90. So that's where that 90 comes from up there. So now let me clear away all this because now we're down to the crunch of the question. This angle in here is 83.74 degrees. Now the question is, how long is the boat visible at point B? And here's the answer. So we know it takes 30 minutes for the Ferris wheel to rotate completely around. There's 360 degrees in a full rotation. So if we say the time it's visible, or the angle out of the 360, which is visible, is 83.74. Divide that by 360, which is a full rotation, which takes 30 minutes. So we're multiplying by 30. We get 6.9783. And we want it to the nearest minute. So it turns out to be 7 minutes. And that is worth 10 marks. So I would suggest and imagine that some people found that last part difficult, but hopefully now after watching the video, it's a bit clearer on how to do it. And you could go back now and practice it so that if something like it came up in the exam, you'd be able for it. Okay, that is the last of our, we'll say, trigonometric, geometric questions. And now we're on to question 10, which is back to the probability stats type questions. Okay, let's have a look at it.